All right, guys. So today what we're going to be doing is we're going to be using U substitution to undo the chain rule. So that means that we have some sort of a chain rule applied to our function that we're trying to integrate, and we need to figure out how to get that undone. So much like how we kind of did the stuff, or we did like f of stuff, we said that if I'm derivating f of g sub x, that would be like f of stuff, so it would be f prime of stuff, which in this case is g sub x, times the derivative of that stuff. So very similar. What this means, if we're integrating a function that we notice you have this similar format, then that integration is f of g sub x plus c. Now notice that I'm using lowercase f here. The reason why is in my integration, this guy right here, this is f prime, so the antiderivative of f prime is f. All right, so how do we know when U substitution works? Because we've been integrating just fine without it. What you're really looking for when you're looking for U substitution is you're always looking for composite functions. What I mean by when I say composite functions is that I mean that you have something like a function inside of a function. In this scenario, my f of x, if I were given f of g sub x, my f of x would be x squared or stuff squared, and my g sub x is that stuff being squared, which would be sine of x. So first let's practice with a function, and let's practice identifying what is u, or what is stuff, and what is the derivative of that stuff. So I already have this table filled out here, just to make it a little bit quicker, but all I mean by that is that if I'm looking for u is what is that stuff? That stuff is 2x, and then the derivative of that, the derivative of 2x is 2, and there it is, that appears right there. Next one, you know that the stuff would be what is my main function? And that would be that 3x minus 11. I'm just going to go down and do it for all of them. The argument, more or less, or what's inside the parentheses. I'm going to leave tangent squared, secant squared last, just because. Be careful here. Now, I know that here's where those derivatives appear. All right there. Let's look at this very last one. Our derivative is secant squared of x. I know that the opposite of, or the secant squared of x is the derivative of tangent of x. So that is my u, that tangent of x. So let's do an example based off this guy above. There is the bell. Our first step is to decide what is the inner function, and we're going to call it u. So in this case, my inner function is 2x. So my first step is to say u equals 2x. Now I know that there is a derivative of 2x in here somewhere, and I do know that du, derivative of u with respect to x in this situation, is 2. So let's kind of figure that out and let's work backwards, because in my function I have dx, not du. So I'm going to work backwards on this guy and solve for dx. So my first step is to multiply both sides by dx and divide by du. So I get dx equals 2 divided by du. So I'm going to rewrite my integral using u, and I want to make very, very sure, this is super important, that there should be no x's left when I start to integrate. I'm doing everything now in terms of u. So the integral of 2 sine of 2x dx is going to be 2 stays, sine stays, but I said let's let u equal 2x, so I'm going to say sine of u. I also said let's let dx be du over 2. And I got that from this guy right here. I'm just substituting all values that I solved for. Once I do that, my 2's cancel out, and I'm left with the integral of sine of u du. I know that the antiderivative of sine with respect to u is going to be negative cosine of u plus c. Very important to remember that plus c. I know it's been a while. All right, let's look at another one because I know that this is going really quickly. Oh, sorry, negative cosine of u. Last step is to rewrite it with my original variable. So I know that u was 2x. So the integral of 2 sine of 2x d sub x is negative cosine of 2x plus c. Ah, my bad for that. Let's do another example. We have the integral of 3x to the 7th plus 11 times 21x to the 6th, and I need to integrate this function. So the first step is I need to get rid of all the x's by finding u. So I know that u is 3x to the 7th plus 11. I also know that du over dx, the derivative of u, is going to be 21x to the 6th. Now, let's solve for dx, because I know du over dx is 21x to the 6th, and I need to substitute only dx into my original equation. So when I solve for dx, du over dx equals 21x to the 6th, multiplied by dx divided by du, or you can just flip those places, and I know that dx is going to be du divided by 21x to the 6th. Now I'm going to rewrite my integral using that u substitution. So what that means is I said this is going to be u, and I also gave dx another value, and I said that that dx value is du over 21x to the 6th. So what that looks like now is it's still the integral, but now instead of 3x to the 7th plus 11 to the 5th, I'm just writing u to the 5th. We still have 21x to the 6th, but I'm multiplying that by du over 21x to the 6th. Now remember, the goal is to get all of our x values to cancel out. So when I do that, this guy right here cancels, this guy right here cancels. And I am now just left with something that I can easily integrate. I have the integration of u to the 5th du, and now I'm just going to integrate with my normal integration rules. I know that I'm going to do an n plus 1 on the exponent, and then I'm going to divide by n plus 1. In this scenario, n is 5, so I have u to the 5 plus 1, which is 6, divided by 5 plus 1, which is 6, plus c. Now remember, we always want to rewrite using our original variable, because our integration is with respect to x, not respect to u. So I need to resubstitute that u at the very end. So my u value was 3x to the 7th plus 11. So I'm just resetting that. 3x to the 7 plus 11 to the 6th over 6 plus c. And you are done. I want for you guys to pause the video now, and I want for you to work on this part A, and then come back and we'll check. So pause the video now. All right, hopefully you have some work done. Fast forward 7 minutes. Maybe not that long. Let's look at this guy right here. Let's call u 4x to the 5th minus 5x, because this is my composite function, or it's the function that's inside of another function. Now, u equals 4x to the 5th minus 5x, which means that du over dx is the derivative of this, or 20x to the 4th minus 5. And that means, therefore, dx is going to be du divided by 20x to the 4th minus 5. Now, this is the information I need right here, these guys, and we're just going to make some substitutions so we can cancel out x's and get our integral in terms of u. So it is easy to do. That means that I'm going to have the integral of the square root of u times 20x to the 4th minus 5 times du over 20x to the 4th minus 5. Well, what do you know? Those cancel. And I am left with the integral of the square root of u du, which means I just need to integrate that. That's the same thing as saying u to the 1/2. I always like to make my my exponents into my radicals into exponents. Wow, hello words. After I get that done, what that looks like, so I add 1, n plus 1 is 3 over 2, so I have u to the 3 over 2 divided by 3 over 2. So I flip and multiply, 2/3, u to the 3 over 2 plus c. And then all I need to do is resub that u value. So I'm going to rewrite this problem, the integration of the square root of 4x to the 5th minus 5x, 20x to the 4th minus 5 equals 2/3 times that u value, 4x to the 5th minus 5x, raised to the 3/2. Or you can say the square root and cubed. So you could also say square root of 4x to the 5th minus 5x cubed. Same thing, but make sure you do that plus c. One more here. Try this guy out on your own. Please pause the video and give yourself a second to try it with trig. All right, we identified earlier that u here is going to be tangent of x. I know that the derivative of tangent of x is secant squared of x, so therefore dx is du over secant squared of x. Now the reason I use that is I'm trying to get my x's to cancel out, and in this situation, if I would have said u was secant, I couldn't go back and forth as easily, so I'm going to call u tangent in order to get as much to cancel out as possible with my derivatives and my u substitution. So now I'm coming about this. I have the integration of tangent squared of x, secant squared of x, and that's going to be the same thing as u squared times secant squared of x times du over secant squared of x, which those cancel. I now get that this is the integration of u squared du, which is the same thing. If I integrate that, u cubed over 3 plus c. Now I already took that tangent out, and I said that that tangent was the u value. So when I sub back in, I get tangent cubed of x over 3 plus c. And we are finished. Work on some of those practice problems if you like, but we will have time to work on practice problems in class.